Hello viewers, welcome back to BakoMaths. And today's lesson we'll be looking at geometrical representation of complex numbers. If you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we'll start with the complex plane. In the two-dimensional plane, that's XY plane, a complex number can be viewed as either 1, a point, and 2, a vector. It is important to know that when working with complex numbers, we use a special version of the Cartesian plane called the complex plane. And these are what we need to know. The first one is that the Cartesian plane changes to complex plane. This means that the Cartesian plane, which consists of x and y axis, changes to complex plane. And also the horizontal axis of the Cartesian plane, that's x-axis, now represent the real axis of the complex plane. And then also the vertical axis of the Cartesian plane, that's the y-axis, also represents or now changes to the imaginary axis of the complex plane. So given the complex number z equals a plus bi, this can be plotted as a point in the complex plane as. So the first approach is to draw our vertical axis and horizontal axis. But we know well that our vertical axis is specifically known as the imaginary axis, and hence we label it as such. And also our horizontal axis is specifically known as the real axis, and hence we label it as such. From the given complex number z equals a plus bi, we know that our real part is a, and hence we indicate it on the real axis. And then we know that our imaginary part is b, and therefore we indicate it on the imaginary axis. We then draw a dotted lines from b directed horizontally to the right, and also draw another dotted lines from a directed vertically upwards to where they converge. We then indicate a point at which these two dotted lines intersect. And finally, we label the point with the given complex number, that's a plus bi. And this illustrates how a given complex number, z equals a plus bi, can be plotted as a point in the complex plane. And so we continue by looking at how the given complex number z equals a plus bi can be plotted as a vector in the complex plane. So the first thing to do is to draw our vertical axis and horizontal axis, knowing that our vertical axis is rightfully known as the imaginary axis, and hence we label it. And also our horizontal axis is also known to be the real axis, and therefore we label it. From the given complex number z equals a plus bi, we know that our real part is a, and hence we indicate it on the real axis. And then also our imaginary part is b, and therefore we indicate it on the imaginary axis. We then draw a dotted lines from b directed horizontally to the right, and again draw another dotted lines from a directed vertically upwards to where they converge. We then draw a line from the origin to where these two dotted lines intersect, and this line represents the complex number z as a vector in the complex plane. We continue, or we finally label the vector as such, and this illustrates how a given complex number z equals a plus bi can be plotted as a vector in the complex plane. Now let's try this exercise. In each of the following, sketch the point of the complex numbers on the complex plane. So our first example is z equals 1 plus 2i. So this can be solved by first drawing a real and the imaginary axis. From the given complex number 1 plus 2i, we can see that our real part is 1, and therefore we indicate it on the real axis. And then our imaginary part is 2, and hence we indicate it on the imaginary axis. We then draw a dotted line from 2, and then another dotted line from 1 up to where they converge. We indicate the point of intersection with a point, and we write our given complex number beside it. We move on with our second example. And with our second example, we have z equals minus 3 plus I. So the first thing to do here is to draw our real and the imaginary axis. From our given complex number minus 3 plus I, we know that our real part is minus 3, and hence we indicate it on the real axis. And then our imaginary axis is 1, and then also we indicate it on the imaginary axis. We then draw a dotted line from 1, and then another dotted line from minus 3. To where they converge, we indicate a point, and then write a given complex number minus 3 plus I beside it. We continue with our third example. And with our third example, we have z equals minus 2i. And this can be written as z equals 0 plus minus 2i, knowing well that our real part is 0 and then our imaginary part is minus 2i. So we draw our real and then imaginary axis. And we know that our real part from the complex number z equals 0 plus minus 2i is 0, and hence we indicate it. And then our imaginary part is minus 2, and therefore we indicate it. So we draw a dotted line from 0 up to negative 2. We indicate our point and write our complex number beside it. We continue with our fourth example, and we have z equals 1. This can be written as z equals 1 plus 0i, knowing well that our real part is 1 and imaginary part is 0. So we draw our real and imaginary axis. We label on the real axis as 1 and then the imaginary axis as 0. We draw a dotted line from 0 up to where 1 is, and then we indicate our point and write our given complex number beside it. We move on with the next set of examples. And in this set of examples, we are going to look at how to sketch the vectors of the complex numbers on the complex plane. So given our first example as z equals 1 plus 2i, this can be solved by first drawing our real and imaginary axis. Knowing well that from the given complex number 1 plus 2i, our real part is 1 and hence we locate it on the real axis. And then our imaginary part is 2, therefore we locate it on the imaginary axis. We then draw a dotted line from 2 and then a dotted line from 1. At where they meet, we draw a line from the origin at the point of intersection. We then write the given complex number beside it. We move on with our second example. And then in our second example, we have z equals minus 3 plus I. So the first step here is to draw our real and imaginary axis. We locate on the real axis as minus 3 and the imaginary axis as 1. We then draw dotted lines from 1 and also another dotted lines from 3. At the point of intersection, we draw a line from the origin out to where they meet. Then we write our given complex number beside it. We move on with our third example. And in our third example, we have z equals minus 2i. This can be solved by simplifying the given complex number as z equals 0 plus minus 2i. So the first step here is for us to draw our real and the imaginary axis. We locate on the real axis as 0 and then on the imaginary axis as minus 2. We then draw a line from the origin up to where minus 2 is, and then we locate our given complex number beside it. We move on with our final example. And with our final example, we have z equals 1, which can be written as z equals 1 plus 0i. So with this, we first draw our real and imaginary axis, knowing well that our real part from the given complex number z equals 1 plus 0i is 1, and hence we label it on the real axis, and the imaginary part is 0, and therefore we label it on the imaginary axis. And then we draw a line from the origin up to where 1 is. Finally, we write the given complex number beside it. So this ends our set of examples. But before we conclude with today's video, let's check out these trials. Thanks for watching. Kindly like, comment, subscribe, and share. See you in our next video. BakoMaths, thinking beyond infinity.